Hi everybody, now we're going to begin the review for test 3. So here you're going to do two questions. The first one is convert 120 degrees Fahrenheit into degrees Celsius, and the second one is convert 90 degrees convert 50 degrees Kelvins into degrees Celsius. So go ahead and pause, try to solve these, and when you're ready, unpause. Alright, so let's start what's given. So for the first one, you have 120 degrees Fahrenheit, and you want to convert that to Celsius. And for the second one, you have 50 degrees Kelvins that you want to convert to Celsius. So these are just plugins. So the first one is the temperature in Fahrenheit is defined as 9/5 multiplied by the temperature in Celsius plus 32. So we can plug in 120 equals 9/5 times the temperature in Celsius plus 32. And doing the algebra, the temperature in Celsius is going to be 120 minus 32 and times 5/9. And the temperature in Celsius is going to come out to be 58.9 degrees Celsius. 48.9 degrees Celsius. And for part B, we wanted to convert 50 degrees Kelvins into Celsius. So the conversion is temperature in Kelvin is equal to 273.15 plus the temperature in Celsius. So the temperature in Celsius is going to be temperature in Kelvins minus 273.15, and that will be equal to negative 223. Well, plugging in first. It's going to be 50 minus 273.15, and that'll come out to be negative 223.2 degrees Celsius. Alright, so go ahead and try this next one here. So just do this one. It says a 0.067 kilogram piece of copper with a specific heat of 376.8 joules per kilogram per degree Celsius is placed on a hot plate. If the piece of copper is initially at 50 degrees Celsius and a hot plate can output 50 joules of heat, what is the final temperature of the copper sample? Alright, so go ahead and pause, try to solve this, and when you're ready, unpause. Alright, so let's see how we can solve this. Writing down the givens, there's a 0.076 kilograms, so that's a mass, and you have 376.8 joules per kilogram per degree Celsius, so that's a specific heat. And you have 50 degrees Celsius, so that's the temperature, and you have 500 joules, so that's the unit of energy, but here this will be heat, Q. And we're trying to find a final temperature, T. We're trying to find a temperature, T. So what this picture looks like is that you have a hot plate that can output a certain amount of heat, Q, and onto that hot plate you place a piece of copper with a mass MC, and the copper starts off at a temperature T initial, and the heat is going to rise to temperature T final. So you're trying to find the final temperature of the copper, where the initial temperature of the copper is 50. So the equation for this one is the heat is going to equal the mass of the copper, the specific heat of copper, multiplied by the final temperature of copper minus the initial temperature of the copper. So here we can plug in. The heat output is 500 joules. The mass of the copper is 0.067. The specific heat of copper is 376.8. The final temperature of copper is what we want, and the initial temperature of the copper is 50. And And so here, doing the algebra, temperature final should be 50 plus 500 over 0.067 times 376.8. And that should give you a final temperature of 67.5 degrees Celsius. So now let's try this one. So this is another vector question. So here it says, given the following three vectors in terms of their magnitudes and directions, find the resultant magnitude and direction. So vector A has a magnitude of 2000 directed at 100 degrees. Vector B has a magnitude of 2500 directed at 150 degrees. And vector C has a magnitude of 600 directed at 250 degrees. And we want to add these vectors together to find their resulting magnitude and direction. So go ahead and pause, try to solve this one, and when you're ready, unpause. Alright, so let's try to solve this. You have three vectors. And so here, since this is more practice, I'm just going to always start off with the table. And you're going to have your x components and your y components. So here, vector A has a magnitude of, we'll put that up here. So vector A has a magnitude of 2000, and a direction A is equal to 100 degrees. Vector B has a magnitude of 2500, and direction of vector B is 150 degrees. And vector C has a magnitude of 600, and the direction for vector C is 250 degrees. So what we're going to do first is just get the components of each. So for vector A, the x component is going to be 2000 times a cosine of 100. The y component of vector A is going to be 2000 times a sine of 100. For vector B, the x component is going to be 2500 times the cosine of 150. The y component of vector B is going to be 250 multiplied by the sine of 150. The x component for vector C is going to be 600 times the cosine of 250. And the y component for vector C is going to be 600 multiplied by the sine of 250. And once you calculate those numbers, you should get that the resultant in the x direction. So our x is going to be minus 2717.6, and the resultant in the y direction is going to be positive 2655.8. And so now you can get the resultant magnitude. So that's going to be the square root of the x component squared, total x component squared, and total y component squared. So 2717.6 squared, and then plus 2655.8 squared. And that will give you a resultant magnitude of 3799.8 units. So the next part is to get the direction. So before you get the direction, always get the reference angle alpha, which is going to be the inverse tangent of the positive y part. So positive 2655.8 over the positive x part, which is going to be 2717.6. And so alpha will be 44.3 degrees. And now to get the actual angle, you check that you have a negative x component and a positive y component. So the angle will be equal to 180 minus alpha. So 180 minus 44.3, and that will be 135.7 degrees.